Welcome to another mathematics video. Now today we'll be looking on laws of indices. We'll be focusing on the first 5 laws, and in the next video we'll look on the other 2 laws. So before we begin to look on the laws, let us just go through some very important information. If I write a squared, we know that the a would be the base and the 2 would be referred to as the index, power, or exponent. Now, a squared is the same thing as saying a times a. Whatever the number is raised to is telling us that the number will be multiplied that number of times. So a squared, or a to the second power, is just saying that a is being multiplied by itself. Likewise, if we had a to the 4th power, it's just saying that we are multiplying a 4 times. So a times a times a times a. If I was supposed to put a number in front of the variable, for example, 4a to the 5th power, if I was supposed to write this in index notation, it would be 4 times a times a times a times a times a. So it is the a that is being raised to the power 5 and not the 4a. So that's very important. So this 4 is just multiplied by the a to the 5th power. The first law states that when expressions with the same base are multiplied, the indices are added. So a to the n times a to the m would equal to a n plus m, once a is not equal to 0. Let's look at an example. We have x to the 4th power times x to the 7th power. We realize that the bases are the same, x, so we'd write back the base, which is x, and then we would add the powers. So 4 plus 7, and 4 plus 7 is 11. Another example, so if we had 4a cubed times 3a to the 4th power, multiply the numbers as normal. So the number part of the base, because remember that it is only the a that is being raised to the 3rd power and only the a that is being raised to the 4th power. So we will multiply these terms as normal. So 4 times 3 give us 12, right by the a, which is the same base, and then we would add the powers. So 3 plus 4, and this is equal to 12a to the 7th power. The second law states that when we have an expression with the same base being divided, we subtract the power. For example, if we have m to the 4th power divided by m to the 2nd power, and in algebra, most of the time you will see division questions written in this form. So it's still division. So if we have m to the 4th power divided by m to the m squared, if we were supposed to expand this, so index notation, we know that the m to the 4th power is just saying m times m times m times m. And m squared is m times m. If we were supposed to cancel, m into m goes 1 times, m into m goes 1 times, and we would be left with m squared, so 2 m's. So the law states that once the bases are the same, then we subtract m squared. Let's look on another example. What if we had 12a to the 5th power being divided by 6a squared? So we would divide the numbers or the coefficients as normal. So 6 into 6, 1, 6 into 12, 2 times. So we're left with 2. We realize that the bases are the same, a. So we write back the base, and we are dividing, so we would subtract the powers. So therefore it would be 2a, 5 minus 2 is 3. So 2a cubed. The third law states that when a power is raised to another power, we multiply. For example, we have x to the 4th power all being squared. So everything in the bracket is being squared. We know that when we have a power, so we have the power 4 being raised to another power, then it is the same as multiplying the powers. So therefore, the answer would be x, 2 times 4, 8, so x to the 8th power. For this example, power for the 4 would be 1, so it would be 4, 1 2 times 3, x squared times 3. This would give us 4 cubed and x to the 6th power. Now we can find 4 cubed. We know that 4 cubed is 64, so 64x to the 6th power. That would be the answer. When we have a base being raised to the power 0, it is equal to 1. Once a is not equal to 0. For example, we were given a square divided by a square. Now, we know that when we have two bases that are the same being divided, that we subtract the powers. So it would be 2 minus 2, which gives us a to the 0 power. And the law states that anything raised to 0 is equal to 1. Therefore, the answer would be 1. Likewise, if we had another example, x squared raised to the 0. So we have a power raised to another power. So this would be x. We know when a power is raised to another power, then we multiply. So it would be 2 times 0. 2 times 0 is 0. So x to the 0 power, which is equal to 1. And the final law that we'll be looking at for this video, any term raised to the power 1 is equal to the term. So a to the power 1 is equal to a once a is not equal to 0. For example, we have q cube being divided by q squared. We know when the bases are the same, we subtract the powers. So 3 minus 2, and this is equal to q to the 1 power, which is equal to q. If we had m, the negative square being multiplied by m cubed, we know that once the bases are the same, we add the powers. So it would be m negative 2 plus 3. This is equal to m to the 1, which is equal to m. So these are the 5 laws that we'll be looking on. One key thing to note, that if you do not see a power, then the power is 1. For example, if we have a times a squared, once there isn't any power there, automatically the power is 1. So in this case, it would be a 1 plus 2, which gives us a cubed. So let's recap the laws. So the first law says that when we have two terms with the same base being multiplied, then we add the powers. Second says that when we have two terms with the same base being divided, we subtract the powers. Third, when we have a power raised to another power, then we multiply. The fourth is that any base raised to the 0 power is equal to 1, and the fifth one is that any term raised to 1 is equal to the term itself. So a to the first power is equal to a. Thank you for watching.